Microphone? All right. Cool. So, yeah, as Leslie said, we are here to talk about Kibana. Specifically, I want to give you a little bit of history of how Kibana got to be where it is now, and kind of where we're going with it. Just real quick, just so I know, how many people have used Kibana in the room before? Okay. How many people were at the Elasticsearch meetup the other night? You can probably leave if you want, because it's like exactly the same. So, I don't want to bore you here. Okay, so no biggie. Okay, great. So about half the room has used Kibana already, which is great. But for those that haven't, let me give you an idea of what it is and how it got here. Kibana is a application for digging into data. It used to be specifically for time series data, but now we just kind of deal with anything. It was created because I was working at a chain of newspapers in the US, and it was this company that owned a whole bunch of newspapers. I know we all like to think of our little hometown newspaper as having a bunch of people in a little room digging up dirt on whatnot. That was not this company. They had dozens of newspapers across the US. As you can imagine, there are two things in the newspaper industry right now. A, nobody reads newspapers, and B, when you do read them, you read them on the internet. And so this company generated an enormous amount of web traffic, much more than you would think. These things tended to come from, kind of referral sources, and we didn't tend to get a lot of direct traffic, but nonetheless, we got a ton of traffic. And it was very, very spiky traffic, right? Like, nobody goes and reads every single news story every single day just because they want to know everything about what the reporters think. They read something because it's interesting. They read it because their friends said something about it, and they ended up there, and they all ended up there at once. And so we were constantly having to deal with this, and you're probably like, oh, well, your infrastructure for dealing with this is probably great. It wasn't great. It constantly had problems, and we had no idea what they were because this was years and years ago when there really wasn't anything great, especially in the open source space, for figuring out what was going on in logs, right? So we had these like collections of shell scripts, and then they were on a wiki, and only the jerk, me, that wrote them knew how they worked. Nobody else ever used them, and half the reason they never used them is because by the time they went to get to them, we had changed the log format, and it was out of date anyway, and they didn't work anymore. So I was constantly having to write new ones, and I got tired of writing them, so I wrote Kibana so that I could stop writing shell scripts. So that's where Kibana came from. Real quick, people who used Kibana have used version 4, the current version, real quick. A few used version 3. 2? Okay, sweet. And 1 I'm not even going to ask because I know nobody used it, although there was somebody at the meetup the other night that had, which was very impressive. Okay, so most of the folks in the room have used 3. So when we went to build 4, we wanted to take the best features of 3 and make everything a little bit better. And so we looked through 3, and we needed to identify, okay, what's good, what could be better, and what could be a lot better. So we studied, okay, how are people using Kibana these days? Now, the first way they would use it was, of course, for discovery. They were searching through logs or some other kind of data, right? Data discovery was what it was all about. And we're like, okay, we need to make that better. We need to make the whole thing perform better. If we want better data discovery, the first step in that is just getting the answers quicker. So we can make the interface better, yes, and we can make the whole thing just plain faster, right? Make the easy things easier. Once they're easier, make them faster, which was really important. The other thing that we saw when Kibana 3 had been out for a little bit, and this was something that we hadn't necessarily anticipated, was that people weren't just using Kibana, they were building new things with Kibana, which was just incredibly cool to us. When I first built Kibana 3, I was like, okay, well, I need a kind of dashboarding platform. I want to be able to make some visualizations and have some charts of stuff. It turns out people saw a lot of promise in this, and because we're open source, they started to dig into the code, and they said, well, if he can do it, I can do it. And they were completely right, and often they could do it better for that matter. So they started building new applications on top of Kibana. They started adding new visualizations. They started even adding new ways of doing queries. And we're like, okay, so what we get out of this is that folks really want flexibility in Kibana. So when we go to build Kibana 4, let's build it in a way that lets them have that flexibility without just having to hack at it. So those were kind of the core, but the biggest difference we wanted to make was in discovery. Kibana 3 was built with what Elasticsearch had at the time. And what Elasticsearch had at the time was facets. Is everybody here pretty familiar with Elasticsearch facets? A lot of heads nodding. I don't see any shaking. Okay. Anyway, so facets are basically a way of aggregating data for those that aren't familiar, right? So find me the top 5 of something, or get me the average of some field. And in particular, that first thing, that was the terms facet. And then there was this other thing called the stats facet. And if you remember in Kibana 3, these things were pretty easy to do. There was a panel that could deal with terms and put them on a bar chart or something. And then there was a panel that could deal with stats, and it would show you the min, max, and average and whatnot of things. And that was because it kind of mapped directly back to these Elasticsearch concepts. The problem is that facets weren't very flexible. So remember I said we had that terms facet and that statistics facet? Well, somebody once decided that, okay, well, I found the top 5 requests to my site. It would be super helpful if I knew what the average time to load each one of those was. And somebody said, we can't really do that in Elasticsearch right now. You can get one answer or you can have the other answer. Pick one. And somebody said, well, look, I need to do this a lot, and I can't do it with round trips a lot. So what ended up happening was somebody copied and pasted a bunch of code out of the terms facet and then a whole bunch out of the stats facet, and they created this thing called the terms_stats facet. Super. I can see how that'll answer every question. So when we went to build Elasticsearch 1.0, we said, okay, that facet thing, it's not really working out. And so the Elasticsearch team built something called aggregations. And aggregations are basically do the exact same thing as facets, but in a very composable way, which of course got me really excited about doing composable visualizations in Kibana. So when we started to look at how we could improve the concept of discovery, we took that kind of level of composability and those steps to solving a problem. When somebody says, I need the top 5, or even, heck, I just need this one thing, and we said, how can we break that down into steps that make sense for solving a problem? So step 1 of solving a problem is often very, very one-dimensional. You have a pretty good idea of maybe what you're looking for. Maybe you think you know what you're looking for. Specifically, you're just looking for one thing, right? You know, okay, I need to go to my logs, and I need to find that failed SSH login. And so you go there, and you find it. And sometimes that's all you need. But maybe you end up with a bunch of them. Maybe you end up with 4 of them. Maybe you end up with 5 of them. Maybe you end up with 400,000 or 500,000 of them. When you've only got one of them, or you've only got 4 or 5 of them, it's not really that big of a deal, right? So if I jump over to the Discover tab of Kibana, and I'm going to jump into my users index here and get rid of a couple of useless fields that aren't actually in there. So I end up with something like this, right? And this is a really kind of familiar view. It's basically just a list of things that are in my users index. And it's really easy to find stuff in there, obviously. I've just got a little search thing up here, and I'm going to search for the JPL News user. And sure, I can find that user. And this is a very kind of one-dimensional way of finding things. There it is. There's the document I was looking for. And even if I want to find what that user was doing, that's still pretty easy, right? If I've got a log of everything this user does, that's still really easy to find. So if I were to jump over into my USA Gov index, by the way, the data set I'm dealing with is the bit.ly US government clickstream. Every time somebody generates a link to a US government website, bit.ly publishes that to a WebSocket that you can connect to and log if you want to. I was lucky enough that somebody else had already done this and made a nice big archive of them for me. because it's a ready source of very real logging data. Anyway, so I can now see everything that the JPL News user is doing. Everything. Every last unreadable thing, right? I basically have no idea what this user's doing. Sure, I can see a few things in there. Sort of. Oh, they did something at May 12th, and they were using the Xenu link sleuth user agent. This is super hard to read. I mean, even if I did something like add time to it and checked where they were going, this is still really hard to read. Even if I sort this by time, right? It's still hard to read. This is basically just logs. I'm not really doing anything appreciably better than grep at this point. It's just, I can see that, oh, the last time they were active is maybe June 30th or something. So this can be useful for limited cases, right? When I'm just doing search and I really know what I'm looking for already and I don't need to see patterns in anything. I don't know about you, but I'm not super good at just looking down a list of things and finding patterns in it. So we really need another dimension to look at, essentially, here, right? I don't just want to see this, like, scattershot of stuff, right? I want to see some additional dimension to it. I want to see things over time. I want to see the ebb and flow of my data, what that user was doing or what other users were doing. Or maybe I don't even know what user I'm looking for, right? I knew I happened to be looking for the JPL News user there because I honestly don't know. I just kind of picked one. What if I didn't know what the most active user on my site was? Is it the JPL News user, by the way? I don't actually know. It would be awfully helpful if I had a chart or something to help me figure that out, if I could find the top users. So, of course, Kibana's good at doing both of these things, and Kibana 3 was good at doing both of these things too. In Kibana 4, we said, hey, look, that needing to see that ebb and flow of things, that's common enough that it's worth just throwing a chart at the top of the screen every time somebody is dealing with time data. You're dealing with time data, you want to know when it happened, and you want to know how much of it happened. Just put it at the top there. And so we did. And we also added a time column by default if you happen to be dealing with it. So I'll drop that other timestamp column I had added earlier. And so there we go. We can see a big spike in the JPL News user. But of course, at this point, we could go and look at a whole bunch of other data too, because we have a chart that helps us figure out when things went on. That said, what about if I wanted to solve the other problem? What if I wanted to see what are my most popular users, right? I could sit here and I could type in every possible user and sit down and record, which one it was, but that would be a big waste of time. So instead, I'm going to drop into this little field list over here, and I'm just going to quickly visualize my popular users. Okay, so there are my popular users. Oh, and it turns out that the JPL News user actually is one of my, top 5 users. But there's a slight issue with where we ended up here. When we were back on that other screen, we could understand the ebb and flow over time of our data. When we're on this chart, I can understand in that entire time span, which happens to be the last 2 years at the moment, I can understand who my top users were in the last 2 years, but now I don't know when it happened. I don't know when they were active, which is kind of a problem to me. I want to be able to understand why the JPL News user is popular. How did they get there? What kind of things do they post? And so I need a way of melding this chart with that other one. And if we think about this as dimensions, we can think about the idea that we have essentially 2 dimensions here, right? We have how many things the user did and who did them. Before we had, what time is it and what happened at that time. So I need a way to meld these together. I can do it on a bar chart, but I'm not going to. I'm going to drop back over to the New Visualizations section. I can either just click the New Visualization thing, or I can re-click on the Visualize tab at the top here. So I'm going to drop into a line chart. And I'm going to do this from a new search. And I'm going to pick my USA Gov index. And I'm going to get a big white expanse of nothingness, which isn't actually totally true. I do actually have something on there. I've got that tiny little green dot right smack in the middle of the top there, which basically just says, hey, look, there's like 450,000 things in here. I don't know what you want me to do with them. This is all I really know about this index. So unless you tell me you need something else, I'm going to give you that. So we're at one dimension now. Let's add another one. I'm going to add an x-axis. Right now, all we're representing is all on the x-axis. So I'm going to add a date histogram. All right. So now we've got a chart that is very similar to that bar chart that we had before, back on the Discover screen. It's a line, right? We've got the same big spike that we had seen on that other one, but now we've got it in line form. And my goal of coming over here was I wanted to meld that user dimension with the time dimension. So how could I do that? Well, I could just show the same chart, right? So I could maybe I could add another axis to this, but that really wouldn't do much for me. Yes, I'd be able to see who the popular users were, but I wouldn't be able to see what time they did stuff. I could add a Z dimension, right? So, right, you've got X and you've got Y, and then one of the really popular things when you're trying to, create another dimension is people like to throw another dimension at you. I'm not a big fan of three-dimensional charts in general. I don't generally believe things should leap off the screen. I don't have a 3D TV, and I don't much care for 3D movies because you can't get behind the things. Right? You've got this chart, but you don't know that the smallest things are always going to be at the front and the biggest things at the back, which means that there's things that get lost and you can't see them. So I'd rather than having the chart leap off the screen for the third dimension, I would much rather pick a better dimension than that, and I'm going to. So right now, if we look at the visual dimensions of this, yes, we can go with length and width, but one of the other dimensions here ends up being the color. And right now we just represent everything as green because it's pleasing and calming and reminds me of trees, but we could probably give it more meaning than that. So let's split that green line into multiple lines. So I'm going to add sub-buckets, and you'll see in a minute why they are sub-buckets. I'm going to split these lines up, and I'm going to use an Elasticsearch terms aggregation to do this, and I'm going to do this on my user field. So give me the top 5 users over time. And I'm going to hit enter. That's a lot more than 5. So, as you can see down here, I definitely just asked for 5 users. But why did I get a whole lot more than 5? So, those of you familiar with Elasticsearch aggregations might actually understand what just happened. What happened was, yes, I asked for top 5. However, I asked for them as a factor of the time. And so what Elasticsearch did was said, well, you asked me for time, and that was the first thing you asked me for, and then you asked me for the users in that time. Well, I had broken down your data set for you, and I had broken it down into these buckets. In this case, I had broken it down into weekly buckets. And so when you asked me for users, I said, well, in each one of these weeks, what's the most popular user? So it went and found the top 5 users in each week. Of course, that changes from week to week, and so all Kibana knew was, well, you told me a whole bunch of users were popular. Here they are, and here they are per week, and you told me who was popular in each week. That's not necessarily what I want in this case. If you actually look at the Elasticsearch request, you can understand how this came to be. We'll skip past. Is everybody vaguely familiar with Elasticsearch requests and how they work, more or less? Ish? Nodding heads, no shaking. I'm still going to assume that you just don't want to tell me no, so I'm going to explain it. Up here, we have the query section. This basically describes, hey, this is the data I want to get. Basically, I want to get everything between these 2 impossible to read Unix timestamps. And then down here, I have my aggregations section. And so within this aggregation section, we can see how Elasticsearch structured this request. On the top level, we have a date histogram. And below that date histogram, we have a terms of the user field. So again, here we're taking into context the time that the thing falls into to figure things out. What we actually want to do is run that terms aggregation first. So find me my top 5 users and give me those 5 over time. So what I need to do is I need to raise this to be above that other one, which I can do pretty easily in Kibana. If we go over to this side, we've got these little buttons here for increasing and decreasing priority. So I'm going to increase that and rerun the aggregation. Okay, so I have my top 5 users over time now, and it's much, much cleaner. Although I still find this to be kind of a visually distracting sort of thing, mostly because I've got all those lines in there, and I don't really need to know the slope of anything right now, so I'm going to drop those out. I'm just going to completely get rid of all of those connecting lines. So now I've just got a bunch of dots. And while this makes it kind of hard to see where things go to and from, I'm more interested in kind of where they were at. And what I can see is way up here, I've got a dot that says JPL News. And JPL News was apparently very popular within this particular week. What I don't know is why. Why was it popular? Why was there a big spike in JPL News? And the way this data set works is that these are all the clicks through Bitly, right? Which means that a lot of people clicked through Bitly for links that the JPL News user had created at some point, right? They created these short URLs and somebody clicked on them. So there's two possible explanations for this, right? Explanation number one. JPL News got really good at marketing, and they created a ton of content, right? They just created a huge amount of links. Maybe they published a whole bunch of blog stories, something. They just tried to hit a really wide market and hoped that a whole bunch of people would want to click on their stuff. The other thing could be that they published one really, really popular article, and that shot them straight to the top. How do we figure out which it was? What happened? Okay, so we're at 3 dimensions now, but we want another dimension that explains to us what happened. So what we're really looking for here is how many unique articles did they end up publishing, basically the unique count within that bucket. We can see that there were 6,593 clicks, but to how many unique destinations did those represent? So we need to pick another dimension to represent unique destinations. And we've got 3 dimensions now, so we need another one. We've already got color, we've got X, we've got Y. What about those dots? Right now they're all the same color. Right now they're all the same size. Instead of having those all be the same size, let's vary that size depending on how many unique sites were accessed. So I'm going to add another metric aggregation here, and I'm going to decide the dot size. Kind of flows off the screen a bit. All right, so I am going to vary the dot size based on the unique count of the destination field. Okay, let's do that. All right, so interesting thing. The JPL News dot didn't really change much in size. And it doesn't look like it changes much in size in general. In fact, many other users publish a lot more stuff than the JPL News user does. So it's not like what they were doing just kind of exploded all of a sudden. They were still doing about the same stuff they were usually doing. In fact, we can get a better view of that because we've decided that we are interested in this user now. They've become very popular, and we're interested in what they're doing. So what I want to do is I'm just going to narrow this down so I'm just looking at the JPL News user for a while. So I'm going to click on this, and Kibana is going to generate some filters for me. So I don't actually want to change the time. I still want to see what the JPL News user had done for the last couple of years. So I'm going to deselect that filter, and I'm only going to apply this JPL News one. Here, Kibana said, look, you clicked on something, and it represents a couple of different dimensions that I've been able to identify. It represents a week in time, and it represents a particular user, which is why it said, hey, do you want these 2 filters or just, some subset of them? So I'm going to hit apply and just bring this down to the JPL News user. So we can see that actually, without the context of all those other dots that were going around, say the Bitly user kind of outweighing everybody, in fact, they did seem to generate a few more things. Let's see, they generated about, exactly 39 unique sites. However, they usually generate, 14, 31, 19, somewhere between like 10 and 30-ish things. But they also usually only get, 200-ish click-throughs. But up here they had over 6,000. So despite the fact they generated double the amount of links, they got, a 60-fold increase in how many users, or much more than that actually, fold increase in how many users clicked on things. So chances are they just had something that got popular. They generated a few more articles, but they received a whole ton of clicks through to that. Okay. So we know that they probably had a couple of popular articles at least. They published a few more, but there were a couple that were obviously very, very popular. How do we figure out what those were? So I don't really super need the splitting by color here anymore, right? I'm only looking at the JPL News user, so I can get rid of this, and it won't really change anything. So I'm going to remove my split lines, and that won't change anything at all because I was only looking at one user anyway. And I don't really care about the time anymore either. In fact, I'm just going to zoom in on this and get a better idea of what went on in this specific time period. Really, I want to know what went on in that time that they were particularly popular. So I don't need time as a dimension anymore. So let's put something else on the x-axis. Instead, tell me what their popular destinations were. I don't know, give me the top, not 51. Give me the top, say, 15 destinations. All right. Oh, okay. So we're back to having little tiny dots again. Why do we have little tiny dots again? Well, we asked for the top destinations along the x-axis. And so each one of these only represents one destination. And our dot size was determining unique destinations within the bucket. Well, of course, since each one of those represents one, there's only one in each, which is actually to our benefit because we've managed to reclaim a dimension. We can reuse that dimension for something else. So if we look at this, we can see that, yes, they had a few particularly popular things. How did those get to be popular? Well, this data set works a lot like the data set that I had at the newspaper I was working at, in that very few people came through the front page, right? Very few people go to bit.ly and just click on some links because they're short. They come to bit.ly, they go through bit.ly because they saw something on another site that happened to use a bit.ly link. So what sites did people see it on, and how was the traffic driven to the site? Was it driven because one particularly prolific site linked to it, right? Did this hit the front page of the New York Times? Or did something happen like it was shared through Facebook or Twitter or something, and a whole bunch of users posted links to this thing? Let's find out. Let's reclaim that unique count destination, but instead of doing destination, let's grab the referrer header. And referrer tells us, hey, where did these people come from? And actually, I want to show you a neat trick in Elasticsearch. Who's used the cardinality aggregation in Elasticsearch? Anybody? No, basically nobody. So cardinality is the thing that does unique counting. Unique counting, especially across distributed systems and very large sets, while we're not dealing with a huge set here, Elasticsearch is built to handle really large sets. Unique counting of very large sets is very hard. Right? In order to determine if something is unique, you need to know if you've seen it before. If I'm just sweeping through all my logs and I want to find, the unique referrers. So I need to know if I've seen something before so I know if I should count it again. The problem is, in order to know if you've seen something before, you have to remember that you saw it. In order to remember that you've seen something, you have to put it in memory. If you have a lot of those things, it's going to use all of your memory. So there's this thing called approximate counting. And approximate counting is what Elasticsearch does if the data set is really, really big. And the way it does it is it essentially, for folks familiar, I don't know why I keep asking people to raise their hands, but familiar with the hyperloglog algorithm? Basically nobody? Cool. Hyperloglog, the way it works is you generate a bunch of hashes. And you use those hashes to determine essentially probability. What is the chance that there's something like this, and how many of it would there be? So Elasticsearch has this optimization where it can generate those hashes ahead of time. So I'm going to pick the pre-hashed version of this, which I happen to store, just because it's fast. It doesn't really matter as much on this data set, but essentially the way storing hashes works is you're trading a little bit of disk space for a whole lot more performance. Okay, so referrers. Okay, so what we can see here is that their most popular thing Not actually all that widely shared. However, the next most popular thing, actually very widely shared. The unique count of the refer hash in this case is 187. So 187 different sites referred to this page. So what happened likely in this page was that it got somehow relatively popular on social media. Maybe it was posted on a variety of news sites. I'm just kind of curious what that actually is. So I'm going to open this up, and I'm going to resort that, and I'm going to look at this one. So what, oh, this one actually. What actually was that? Okay, so it is apparently Curiosity's heat shield in detail. This apparently got very, very popular. I guess I'm not all that interested in it, but okay. I guess I could see how that's. I mean, it's Mars. That's pretty cool. Anybody see this? Has anybody seen this image before, by the way? I had never seen this until the other night that I gave this. Really? Maybe you were one of those clicks. I bet you were. I bet you were. I bet we have a, like, especially if you got to it from Twitter or something, because this contains a lot of t.co links as well. So there's actually an excellent chance that you are in that data set somewhere. That's neat. Okay, cool. Back to that. All right, so anyway, that's essentially how Kibana deals with a whole bunch of different dimensions. It lets you map up some dimension of the data to some visual dimension of stuff. And it's kind of a flow that we found that we went through a lot when we were using Kibana 3. We would first start searching, then we'd realize that we didn't actually know what we were searching for, and so we'd go and we'd create a whole bunch of these panels, right? The problem is that Kibana 3 was really designed to search and have a dashboard. But sometimes you just didn't need that answer over and over and over again. You didn't actually need it on a dashboard, which is why we built the whole visualization aspect of this. Sometimes all I needed to know was that a picture of a heat shield was a really popular thing. I'm not going to need that to know that tomorrow, and I probably won't need it on a dashboard. If I got to an answer that I would need to know repeatedly, such as things like how big are the files I'm serving, how many unique visitors do I have every day, those are the kind of things I end up putting on a dashboard. The idea is we were trying to build a flow that allowed you to get just the amount of information you needed without forcing you to save it in some way or keep it around for later or put it on a dashboard or put it into kind of a fixed panel. So of course Kibana lets you save these visualizations and reuse them. If I had needed to see that, chart of the JPL News URLs, I could have saved that and put it on a dashboard. I could have put it on multiple dashboards. Not only that, but right now I'm mostly looking at my USA Gov data. If I had other data, I could put that stuff on a dashboard too. Kibana 3, you could only link one index to one dashboard. Kibana 4, as many different indices as you want, which actually brings up something kind of neat. Let's go over to my dashboard real quick, and I'm going to get rid of the JPL News user because I don't really need to know about them. So, an interesting bit here is that, yes, I can put multiple things on. Go over here. I actually want to see more than just that tiny slice of time that JPL News was active. Okay, so interesting bit here is that I have these two indices. I have the USA Gov index and I have this users index. And they both share one common trait, and they're both associated with a username. And so because I have that field user in both places, I get this neat kind of client-side join effect, essentially. So let's see. I have down here a table of my top users. And again, we've got JPL News user there and all these other ones. But I'm going to pick on JPL News again, and I'm going to click that bar. And since that only represents one useful searchable dimension, Kibana just goes ahead and creates the filter for me. And okay, so now I can see where the JPL News user was popular. So mostly in Europe. It turned out that most of those link clicks came from Europe. And because I have on the same dashboard the users index and a list of all the users, that gets filtered at the same time. So now I also have all the details about that user, even though it was stored in a separate index from all the event data that I was normally looking at. I get to get all the context about that user. Because we were making dashboards this much more powerful, and because we were introducing so many new visualizations, and because we were using aggregations, and because the questions we let you ask got more complex, we really needed to speed up the way that Kibana did things. So in Kibana 3, here's what happened. You had 15 panels on a dashboard, which is a pretty complex thing. What Kibana would do is it would say, deal with it, Elasticsearch, and it would just chuck a bunch of HTTP requests at Elasticsearch. Now, there was an issue with this, and that's that it often didn't chuck them directly at Elasticsearch. With Kibana 3, you had to have a web server, and many people decided, well, I'd rather set up a proxy and have Kibana talk to Elasticsearch through that. Totally reasonable. The problem would be is that a lot of people would grab an example for, say, Apache or something off the internet, an example of a reverse proxy, and that reverse proxy configuration would have this line in it that said, don't let any more than 3 connections per user through at a time. So I've got 15 things, and the browser just generated 15 HTTP requests. So the browser's going to sit there and spin. It's just going to sit there and wait until it can issue more requests, which means it thinks it's going to issue 15. Apache's going to say, no, you're not. You're going to issue 3. And so what's going to happen is, in order to get to that 4th request, it's got to wait for one of the first 3 to finish. To get to the 5th request, it's got to wait for one of those 3 to finish, so on and so forth, which means that you're constantly sitting there waiting for stuff, and while you're sitting there waiting for stuff, there's new data coming into Elasticsearch, right? So by the time we actually get to like the 15th thing, who knows how consistent our answers were, besides the fact that it took a really long time. So how did we solve that in Kibana 4? We got rid of the need to set up a proxy. We just build a backend in. We do essentially the proxying ourselves with a minimal amount of restriction on it. So we keep things to like non-destructive GET requests. We let you write to the .kibana index, but that's really the only index that you get to write to. The other way that we solved this is we said, don't chuck 15 HTTP requests all at the same time. That's not particularly efficient. Elasticsearch has a better way of dealing with that. We just bundle everything up into one big request now. So instead of issuing them all separately, we put them all into the Elasticsearch msearch API, and we make sure that Elasticsearch runs them all at the same time, right? It never made any sense to just run 3 at a time when you've got, 5 or 6 Elasticsearch nodes, and each of those have multiple cores. Why am I just running 3? Just run them all and let Elasticsearch figure it out, which it does quite well. We found that on complex dashboards, things that were asking a lot of questions, we were able to reduce the query time from an annoying 30 seconds down to a slightly less annoying 10 seconds. A pretty decent increase. Not only that, but because all the questions were asked at exactly the same time, they all have the exact same view of the data. That's essentially how we addressed both the data discovery and the performance aspects of things, as well as some of the flexibility. And we did most of that in Kibana 4. We recently released Kibana 4.1. 4.1 came with a whole bunch more performance improvements. The big one being that when we went to design Kibana 4, we were like, okay, we need to cache a bunch of stuff, right? We're moving a lot of data around, and it's important that we cache things. Well, of course, the problem with cache is that cache is essentially, again, remembering what just happened, and remembering things, again, takes memory. And so we did a pretty good dive into, okay, this caching that we're doing, how effective is it really? And it turned out it wasn't as effective as we wanted it to be. So we got rid of a lot of the caching, and that actually ended up speeding up a lot of things. In fact, in some places, Kibana 4.1 is somewhere on the order of like 10 times more memory efficient than 4 was. Now, a lot of that was cleaning up some code that we didn't love. A lot of it was just getting rid of caches that we weren't using. Kibana 4 is a lot faster. Of course, Kibana 4.1 is a lot faster. Of course, we brought in some new features too, such as filters. We've made them better. We've added some functionality to them. For example, geographic filtering, right? I can do geofilters now. So if I want to see just this point on the map, I can get just that point on the map. Another thing that we added was filter pinning. And this was to solve the problem of I answered a question here, but I have the same question somewhere else. I'd like to use the same data in another part of the application. I created all these filters. I don't want to create them again. Can you just keep them around for me? So we added filter pinning, which basically just says keep this filter. So I'll select the little pin icon, and wherever I go from now on, keep that filter. So when I go over here, I've still got this geo filter, which means that all of these things are still relevant to that specific geographic area. If I had selected, a user, time range, all of that stuff just sticks with me. And of course, I can still get rid of them and see everything. The other thing that we added was field formatting. So you put stuff into Elasticsearch, and it's in a format that you need to be able to search on it easily, right? So I do something like, I have a bytes field. I don't store that as 80 KB, right? I don't store it as 80 kilobytes. I store it as 80,000. But when I go to actually look at it, I don't constantly want to look at 80,000. I want to look at 80 KB. So that was something that we added, was the ability to have custom formatters. So if I add bytes here, I can see that, yep, I actually get that in the proper format. And I also added URL links. So we have these field formatters that let you say exactly how you want the thing to be displayed. So in this case, I was storing URLs there. I want to show them as links. That URL formatter actually does other stuff. Even though in this case we happen to have URLs in there, you don't actually have to have a URL in the field in order to create a link to it. For example, let's say that you stored the ID of something, right? Maybe I've got user ID in that list, and I've got some other application that I use for managing users. This URL formatter is actually templated. So you can use that value and insert that into a URL. So you could say link off to another application or something for context. This is one of the places where we first started introducing real flexibility into Kibana. On a developer level, this is the first place that we've really started to document the API for doing this yourself, because we said that, look, we can hit like a really broad use case of what people want to do with showing values of fields, but we're not going to get it all. We need something so that people can do this in a custom way, which we added. So now if you go in and look at our existing field formatters, you can come up with your own. They're all written in JavaScript. They have a differentiation between looking at things in text, for example, in tooltips and such, and then having them represented as HTML for something like this. So you could do things like make images in line, or you could code a field with some color depending on what its value is. Any other of custom logic that you want to introduce. And we plan to kind of continue this trend of making things expandable. We're documenting the APIs that we use to build features in Kibana very constantly now. So the next thing that we're building in Kibana that we're really excited about is authentication. This is something that we're working on right now. And when we started working on it, we again said, this needs to be flexible. People need to be able to do this their way. Sure, we can build authentication systems that hit a pretty broad spectrum, right? We know that we can integrate with Elasticsearch Shield because that's easy. It's like the thing people use to secure Elasticsearch. But we know that that's not the thing that everybody uses. So we want to make sure that for authentication, you can integrate with, say, your corporate auth system. So we're building this in a pluggable way. If you go to the GitHub repository, there's a ticket explaining all about how we're going to build pluggable authentication, something that we've already started on. The other thing that we're doing is we're trying to allow you to extend other parts of the application. For example, building your own visualizations. We're starting to document the visualization API so that if you have a particularly niche thing you've got some way that you want to see your data. Maybe you've created a visualization as a standalone thing. You want to bring it into Kibana. It's something we want to start allowing you to do. In addition, you may have noticed that I haven't been swapping back and forth between like Keynote or PowerPoint or something during this. Before I gave the talk, I wanted to see, well, how easy is it to extend Kibana to add completely new functionality? So I built a slideshow app for Kibana, which is why I have that little slides tab at the top. This is built with Reveal.js, which is just a really simple JavaScript framework for making slideshows. You don't actually need to know anything about Reveal.js or JavaScript to use this. They have an online builder for these that's all nice and point and click. If you grab the stuff in this GitHub repository and drop it in your plugins directory in Kibana, it'll add a new slides tab for you. If you replace the, I think it's called like offline.html, if you replace that with your own slides that you build on the online Reveal.js thing, you'll put your own presentation in there, and it'll just kind of work. But it's about the simplest app you can imagine. If you are a developer, you can go into it, and you've got kind of a very lightweight seed for building your own stuff into Kibana. We also want to make sure that all of these things are always available to you. We're an open source company. Everything we do is in the open. We haven't closed sourced anything in Kibana, and we don't plan to, which means that we want you to be able to use stuff as soon as it's available. So we've started publishing snapshot builds. And while I just gave you a nice diatribe about how we want to share everything, mostly these are self-serving. We really just want to sucker you into being beta testers for us, which has been great for us because we started publishing these right before Kibana 4.1, and we got tons of feedback. I'm actually shocked at the number of people who are willing to use something like way before we've QA'd it at all. But served as a great test bed for us. We fixed a ton of stuff that, hey, maybe we wouldn't have found. We also improved the behavior in a lot of places. People said, hey, this could be just a little better here. And it's because we give early access to everything in an easy-to-consume way. So please, grab it. Let us know how we can improve, find bugs, fix bugs. And that's about it.